innovation and excellence in the telecom sector, he leverages his extensive experience to drive impactful solutions that enhance connectivity and improve user experience. Based out of Singapore and affiliated with the National University of Singapore, please put your hands together for Mr. Ludwig Landgren.
How are you doing, everyone, this afternoon, first day of IMC? Swabat ka mitru ka hen. No? I'll try that again. Sabi mitru ka swagat hen. Welcome, welcome, friends. I think we're all friends in this industry, and it's really great to speak to you about edge computing and what we can do in the edge. So I'd like to ask perhaps for my slides to be put up. I'm based out of Singapore. I lead the OSS, BSS, and core division in South Asia, so India, Southeast Asia, and ANZA. And what I'll talk to you about here today is edge computing. And I'd like to remind you of the slogan of this show, thank you, which is, "The future is now." So think about that. The future is now. 5G is now deployed in wide scale in India, but we need to do one thing. We need to make 5G make money. And the future is now. So 5G deployed is a fantastic highway to provide consumer and enterprise services, but there's one thing missing. There's one thing missing. What is that? And it has to do with the edge. So I think many of you've got 5G phones in your hands, but all of us in this room have exactly the same experience. Good or bad, we have exactly the same experience. Nobody is sitting in first class. Nobody's sitting in business class. Nobody's in economy. We're all in exactly the same package of data in our network. And with 5G, and particularly with 5G SA, there's a possibility to differentiate. We can differentiate by slicing the network, by creating hybrid network models, and this is what customers are doing today, and this is what I foresee is going to happen in a big way in India. And you can look at the amount of momentum we have here at the IMC with all the companies involved and all the willingness to differentiate customer networks. So let's look at it. This is sort of how a normal network rollout starts, right? We start with 5G introduction, NSA. This started already in India in a very rapid way. So we're pretty much, nearing to a 5G SA nationwide for some operators in India, and the others following closely behind. And then, of course, in the future, we've got 6G and are supported across the whole network. But the real important thing is not only the network rollout, it's also how you use the devices in the network. And that's on the top here. That is the differentiation. Because all of us have only one subscription in our phones. One subscription. But with 5G SA, we can introduce slicing and orchestration, and we can have multiple slices or multiple subscriptions on the same device. So it's multi-pay, multi-subscription on the same device. Okay, so how does then edge play out in this? Oh, it's an old set of slides. So edge plays out in many different ways in terms of where you put the network functions, and these applications will need it. So the differentiation, of course, for us we need it, but also for enterprise applications. So autonomous vehicles, AI cannot use the handset. Of course, there will be a certain amount of AI that will be put on the handset, but everything cannot be there. You have to put some of the capability in the edge of the network, because the capacity is just not enough. So by creating a network edge and have computing in the edge of the network, you can start to enable all of these different services and then provide a better experience for the customers, meaning that you can create these different classes of service and the different slices for customers. So the really good thing is if you look at it, you have the green bar there, the best effort MBB business. That is the base. That's what we have got today. But with adding edge and adding slicing in the network, then we can have performance-based and platform-based subscriptions. So what is that? What is performance-based and platform-based? So performance-based means that you have certain criteria that needs to be followed in latency or in minimum bandwidth. That's performance-based. What is platform-based? Platform-based is when you're starting to use APIs in the network, and you're starting to expose them so that enterprises and consumers can themselves initiate these services. That is platform-based. And the really good thing is that both of these two services, or these applications of 5G, is on top of the MBB that we're doing today. And this is really good, because then we're making 5G make real money. So it's really about how you deploy the data in the network. And this is an example of how the edge comes into the core of the network, where it can either be a public cloud or a private cloud, where you deploy the complete data center. And the good thing is that you can divide it in many different ways. You can go the extreme. The extreme would be a fully private 5G network, where you have all of the functions, the subscriber management, the user plane, the subscriber management as well, all of those applications in the edge. Or you put only part of the services in the edge, which is the user plane, and then you combine that with the slicing of the network. So these are some examples of customers that are doing this type of edge and slicing today. So let me start with Singtel. So I'm based in Singapore, and I experienced this service myself. It's the same thing in Singapore, that everyone has basically the same service. This was the situation in 2022 when they launched 5G, and they launched SA nationwide. Everyone had exactly the same service. But they wanted to provide advanced, improved service for one set of customers, which was this. Do you know? Do you know the example in 2022? So it was Formula One. So Singapore is big about Formula One, and they wanted to ensure that all the Formula One spectators, they would get an excellent experience on their phones in this crowded area and have fantastic service. So they launched an event pass, which is effectively a slice of the network for these subscribers. So they paid money for that, not so much, a few dollars for those few days. But the really good thing was not the monetization of that one time. It was not that one time, those 3 Formula One days. What was the real benefit? The real benefit was that Singtel was able to move a mass amount of customers from 4G to 5G, which had a little bit of a bigger data bucket and a possibility to monetize over and over again every month, because then these customers were 5G subscribers, so they moved them from 4G to 5G. But there's one problem. So for the guys that signed up to this F1 pass, everyone got exactly the same service, no matter what application they used on the phone. You know, whether they used a Teams application, a corporate application, whether they used YouTube, or whether they were just browsing the internet. They got the same service, which is, sounds fantastic, but actually it's not. Actually, it's a missed revenue opportunity. So Singtel was also the first to launch something quite unique. And that's a technology called URSP. So by using URSP, you're able to differentiate between the different applications, which applications you push on the phone, and you initiate the slice. So this is something they're introducing right now in their network, so that you can have differentiated service depending on whether you're using corporate applications or you're using consumer applications. And the really good thing about this is that it provides a possibility for not just you and I to be paying to the OpCo, but also for customers or enterprises like, for example, Microsoft, who has Teams, to be a revenue channel to Singtel, because then they initiate a slice on the network for their customers. AT&T is doing a similar thing with Turbo. Telstra also has a bandwidth and optimization service in their network, and the one with Telstra is pretty advanced, because they offer it to a point where they also have an SLA with the enterprises that are using this. So the enterprises, if they do not get the service, and they can real-time monitor, if they do not get the service, then they don't need to pay. That is pretty cool. Far EasTone is another example, and this one uses edge. So Far EasTone uses the edge of the network by putting something we call a local product packet gateway. So an edge device, so that all the user plane is in the edge of the network, which means that they can very quickly process that capacity or that traffic that's on that slice. And it provides two advantages. One is that it provides a possibility for security, because we're talking about police force. So it's a secure slice. The other possibility is that it provides very quick latency, which means that what they do is they check vehicles for stolen vehicles, so the police can immediately detect whether this is someone that they want to catch or not. So it's pretty cool services that we can use with differentiating 5G services. And it really changes the way that we use these networks. This is another example of modern mining. So it's a Swedish company called Epiroc. I don't know if you know Epiroc. Epiroc, they have about 40 to almost 50% of the underground machinery in mines. But they've got a big problem. People need to drive these machines. And that's dangerous. The other dangerous thing is that not only for the people that are driving the mines, or driving the trucks, but there are also other machinery and other people that are in the mines. And they were using Wi-Fi. They were using Wi-Fi in the mines for the communication services, but they could not connect the machinery to the Wi-Fi network. One, because it was too cumbersome. It was many devices. So instead, what they did is they provided a private network in the mine to ensure that they could connect all of their machines. And it needs to be pretty precise, because mines are really tight spots. So if the machine, and these are big machines, the diggers and the drillers, if they do a wrong turn or come too close to the edge, and you've got humans there or you've got another machine, it's not good. So it needs to be precise. And the only way that they could make it precise was with 5G. So I've given some examples of how we can differentiate with 5G, and particularly with 5G SA, and it's a tremendous opportunity for India. So 5G SA is here now, differentiation is here now, and these are many examples of commercialization, of slicing, of using the edge that's happening right now. So a tremendous opportunity for India. Please enjoy these days. Enjoy the panel, and thank you so much for your presence today.
Good afternoon, everyone. Now let's welcome our panelists for the session Innovating the Edge, powered by the Cloud Part A. First up on the panel, we have Mr. Girish Dave. He is the head of 5G, 6G, and AI Solution Management at Jio Platforms Limited. Please give a big round of applause. Next up on the panel, we have Mr. Rohit Kumar Chaudhary. He is the Telco Solution Architect at HPE. Following him, we have Ankur Agarwal, CBO at Space World. Next up on the panel, we have Mr. Sumit Gandhi. He is the Director of Software at VVDN. Please welcome Mr. Jayant Nagarajan. He is the Head of Telecom Industry Asia Pacific at AWS. And Mr. John Williamson, Senior Director at Ola. Moderating the session, we have Mr. Sri Krishna Sundarajan. He's the partner at KPMG Digital Solution Strategy and Insights.
Good evening, everyone. In the interest of time, I'm thinking, can we skip the long introduction that we have got? Is that okay? So that the audience get to benefit more from your insights before the next session starting at 5. Okay. So delighted to be moderating this distinguished panel. And when we are preparing for this, I found that the collective experience of this panel is probably close to about 150 years of experience across this whole space of cloud, edge, and the core telco and the underlying IT parts. So I'm as excited as you to get to hear the insights from the team. So this is on cloud plus edge. The convergence of cloud and the edge actually is a transformative shift. In fact, new business models are being created, etc. And also the data search through IoT, etc. Makes it interesting. But I am as interested as you are in kind of understanding the broad impact and also the benefits to the business. I'd like to start from John, who has traveled all the way from Taipei to be here with us. John, how is the convergence of cloud and edge computing transforming industries, and what are the key benefits to businesses, if you may start?
Awesome, Sri, thank you very much. And good afternoon, everyone. I see 3 key benefits when you can combine cloud and the edge computing. When there are new services, that always produces growth. We're already seeing edge devices themselves become more and more capable, being able to interact when we speak to them, to understand our voices, to help us with some automation tasks. And on the cloud, we see this huge emergence of AI, the large language models and applications and services that are really only limited by the amount of GPUs we're able to get our hands on. But together, that's where you start seeing much more innovative customer services really driving that level of growth. You start seeing the AI being able to answer much more elaborate queries, the AI on the device working out which AI or content and services that would be able to answer your questions or to help you with your creativity, really driving that attachment and growth and the usage of the devices that we have in our hands. But it's not just about AI. Even IoT devices that are providing data into the networks, into the cloud. The cloud can use its intelligence to derive information from that data and make those services better and better. This is a flywheel that helps stimulate growth. Right? To take advantage of this potential, we really have to learn how to scale, and that's also where AI and the cloud-based resources can help us. When you start spending the energy to generate a large language model or an advanced AI solution, what you're really delivering is the opportunity to scale. If you're looking at a customer service application, you don't need one agent answering every customer. AI can do that for you. That's how you get that scale and growth. Where we see convergence is where do you perform that computation? Does it make more sense to have that operation done in the cloud? Or as edge devices get more capable, are they able to take care of that workload? So those precious GPU resources you have can, again, focus on that flywheel, making the AI service more compelling, more intelligent. Right? I think that's the second key area. The third area, which is disrupting business, is in convergence. Because these advanced services, which are unprecedented, can only be done with this combination between edge and cloud, many companies are looking at this from a vertical perspective. They're looking at the real-time sensors that we use on the devices, the silicon choices that we're using, the operating system, the customer interactions, gaining data from all of these, connecting to the networks, connecting to the cloud storage services, connecting to the information graphs and the AI and the other online services behind that. And we are starting to really optimize across that vertical when we are doing things like product and service design. Now that's a challenge, but it is certainly a way that's disrupting industries. But when you combine that with scale and that potential for growth, that's where I see the potential for all the companies in this room to really capitalize on AI and the services, the new services that are offered there.
Excellent. Thanks, John. So you touched upon AI right at the beginning. I thought we'll probably cover it a little bit later. Jayant, would you like to add your perspective on this topic?
Happy to. Thank you for that, and good afternoon, everybody. I agree with everything that's been said so far. I just add a couple of other perspectives, and given that this is a telco conference, I'm going to kind of give you some examples with how the telcos are at the center of all of this. First off, I think we look at the cloud really as a continuum. So I don't see a discrete kind of stopping point for the cloud and then for the edge. So I guess I just wanted to get that for a level set for everybody here. And the general ethos that we look at here is we look at it as a continuum for a workload that needs to run wherever it is most relevant for the users that it serves. That's kind of the definition of how we look at it. So with that being said, I think the convergence really is, it comes down to a matter of where the data needs to be processed for maximum efficacy for the users, for the use cases that they need. That's the kind of approach that we would take to it. And with that said, there's a few kind of scenarios that I think in macro levels we don't have all day, so I'm going to just pick a few scenarios. First off, I think there is the actual laws of physics, which basically are immutable. And in those cases, there is a cost to processing data at a different location, and there are benefits, and there are use cases that would benefit from having the data processed closer to where the actual user is using it. Great example of this is an autonomous self-driving car, a robot, or for example, somebody that is performing virtual surgery, which we have examples of with Apollo hospitals in India, or for safety for workers, which is a big theme even in India, right? So Spark in New Zealand, for example, ran a private 5G network with Curious, one of their subsidiaries, to detect with a camera feed when a worker was going too close to an excavator and immediately sounding an alarm, right? So worker safety scenarios are a big example of where industries across the board can benefit from it. The second scenario that I think is very important with the edge again is that of latency again and responsiveness. A good example of this is our vision. When you have the kind of vision that we do, if you're adding a little overlay, it's very, common to see people wearing headsets these days or augmented reality glasses. What we're seeing is, the gentleman before on the keynote spoke about F1. With National Hockey League, with National Football Leagues, we've seen telcos like Rogers in Canada now do edge fan enhancement, where they're actually getting live updates, they're actually getting overlaid statistics as well. And this is one that fans across the board in any sport can use. Last but certainly not least, I think there's a whole lot of cost efficiency and a general sense of new use cases that are possible, I guess, alluding to the point that you had as well. And cost efficiency is the less data you need to transmit, the more efficient it is, for obviously, for a variety of reasons. And a good example of this is with Verizon. They put a private mech at customers' sites, and they had the opportunity then to control those autonomous robots right there without having to backhaul data a whole lot further. So I think broad themes, we see a whole lot of benefits for industries across the board, and we think the ability to compute wherever the workload needs to be addressed to manage the use case, I think that really is where we see the convergence making a big difference to transform industries of all kinds.
Excellent. Thanks, Jayant. Just wanted to check, how many of you use DigiYatra for domestic travel over here? Okay, that's a sizable number. So I had an opportunity of working with them in this project, and to Jayant's point about the trade-off between computing on the edge or on the cloud, right? For example, the face match algorithm or the liveness check, etc. There is a trade-off even over there. A live application I just wanted to bring from the earth movers to something that each of us also kind of use. So talking of this, no one can ignore how much important security and privacy is, especially in this cloud plus edge continuum. Girish, coming to you, wanted to kind of get your perspective on how do these cloud and edge solutions, does it work? Okay. Address security and privacy concerns. What have you seen as the kind of best practices for ensuring data protection?
Hello. Yeah, thanks, Sri. So before I answer this question, I would like to check upon you that how many of you here are cybersecurity professionals or have any background of the security aspect, be it from the network perspective, application perspective, or the infrastructure perspective. Excellent.
I
So
see three people.
we have a fair amount of. So I'll then keep my language accordingly less technical. So when we see the cloud and edge, uh, if you see these two pieces without any kind of a connectivity or application onto it, they are like a island, somewhere in the center of a sea without any habitation or without any kind of a human life. So if we have to, bring a life to that island, then we need a connectivity. And believe me, the same approach holds good for the cloud and edge as well. So what has really, changed for the cloud? If you remember that when the broadband was in its nascent stage of the technology, you would have seen the fate of the cloud. And when the broadband became, ubiquitous, especially the mobile broadband, underpinned by the growth of the smartphone, we have, seen how the cloud has, grown from right from there. What the broadband has done to the cloud, similarly, the 5G is doing the same to the cloud and the edge story. And then comes the application. 5G in itself is an application. At the same time, then it harbors the different set of the applications which leverages the same cloud and edge infrastructure. So just to put it like this. Now what happens is that we know that one of the very fundamental basic security measures that we take in our environment is the encryption. So what happens is that within the 5G we have the encryption mechanism which holds good the basically your subscriber information by encrypting this information at the rest as well as while it is in the transit. Now within the geo, I'll share one very interesting case that how we secure the network basically. So of course we are taking the benefit of the 5G standalone architecture which is fundamentally cloud native, unlike the NSA architecture which most of the people you would have been seen deploying it, and which I very comfortably call it as a recycled 4G basically. It is not a true 5G. I must say that. And that is a path anyways every operator will have to take sooner or later. But you would see that within this framework we have deployed this post quantum safe cryptographic technique as well. So what happens with the help of that is it becomes a quantum safe network, that today if the hackers are exploiting the quantum technologies to hack your network, compromise on the security or the confidentiality or the integrity of the network or any information, it is become kind of, it is very well taken care with the help of this PQC technique. And these are the algorithms very well available which are advanced than your traditional algorithms like RSA or ECC or so on and so forth. Next in line is the basic fundamental architecture of cloud and edge. Edge allows you to do the local processing of the data. Now that itself is a secure way of handling the data where you are reducing your traffic in the transit. And you will observe that most of the attacks or most of the the penetration happens in the centralized cloud data center, whereas the edge are relatively safe for that part because of their obscurity or because of their locations or because of too much of the distribution, whatever aside. So that itself brings that the safety within the network. So that is a kind of a additional icing on the cake. Next in line is the access control that now today the IT fraternity is also learning from the telecom world that telecom is excellent in providing or maintaining or monitoring or controlling the role-based access control across the network, which is like fundamentally has been missing somewhere, but now it is happening. And last but not least is the automation, which is like the unsung hero in the whole game. Automation today has become somewhere the synonym of AI, but I will not say that it is exactly the AI. AI has an overarching impact across all the elements of the network application infrastructure. And AI is like a new electricity, right? So as we need the electricity for all the domains, similarly AI has become like a ubiquitous, omnipresent everywhere. But automation, when I say, is like when you do regular software upgrades, when you are doing the configuration changes, what essentially you are doing is basically removing the element of human error. Without any human intervention in a scheduled manner, you are able to do all the kind of the upgradation, software patch updates in an automated fashion through the hitless software upgradation, and most important, without any scope of human error, and creating a very standard operating environment. And other than this, we can always have those standard practices like doing those penetration testing, you're creating the awareness among the employees and so on. So those best practices remains the same, but these are the essential four elements what I said around the encryption, post quantum cryptographic algorithms, your role-based access control, and your regular software upgrades and patching, which greatly helps you to secure your network and really prevents the hackers from exploiting your network. And this is very well like tried and tested, at least in our Geo network. Thank you.
Thank you, Girish. You touched on quantum too. So people have heard of Y2K. How many have heard of Y2Q? Okay, probably that's for another session. The year when quantum will break the current cryptography, right? So people have already started preparing for it, and it's important to be aware, right? As I go to Ankur, I just wanted to touch on one thing. So Nandan Nilekani said in one of his books, uh, micro is the new mega, right? Kind of. So many of you might have heard of the Open Cloud Compute (OCC) initiative launched earlier this year. I read about these micro data centers, 25 kilowatts to 300 kilowatts, highly energy efficient. Interestingly, India has only 10 of them, right? I just wanted to turn to Ankur on asking what roles do micro data centers play in supporting edge computing, and how do they enhance the efficiency, scalability, etc. Ankur, given your background, feel free to also enlighten the audience about some of the infrastructure related aspects related to this.
Thanks, Shri. So I think the benefits of edge, the applications that require edge are very, very clear. We have been talking about it. We had that in the keynote. However, to deploy our edge, infrastructure needs to be available. And I think one of the key components of infrastructure is the data center. You're talking about IT applications who need, the whole environment that would be there in a full-fledged data center. But now we need these applications or these data storage as close to the user as possible. So we're talking about remote locations, we're talking about factory shop floors, we're talking about tier 2, tier 3 towns, where we need this kind of data center setup where we can run these applications. The challenge is really setting up all these data centers, and will we get the return on investment when we set up this full-fledged data center, or can we set these in remote locations? I think that is where micro data centers come in. As Shri said, micro data centers are, there's a vast definition, but one way to look at it is, these are at the smallest unit a prefabricated data center, a data center in a box, if I may, which could be one rack, a couple of racks, going from a few kilowatts to maybe 100 kilowatts, and they can be deployed everywhere, anywhere, and kind of quickly scalable, modular. You can, quickly add or reduce capacity. Deploy these data centers on shop floors because they're rugged, they are kind of prefabricated. So in my view, micro data centers, or call it a mini data center if you may, actually play a huge role to be able to support this newer applications, because you really can't afford to invest in large data centers to start with, at least.
This is interesting. So as the world is going after 1 lakh GPUs to train LLM models and thinking about having nuclear power plants to fuel data centers, looks like India is also looking at the other angle of micro data centers, right? So
Yeah.
thanks, Ankur. Sumit, I wanted to come to you. So we are talking about edge and cloud. Many times latency has been a big concern, right? So I just wanted to get your perspective about how edge computing helps address the latency issues, especially for data intensive applications. What performance improvements the businesses can expect by shifting the processing closer to the edge? Closer?
Thank you. So when we talk about latency issue, we have been talking about a lot of benefits of this edge computing, right? In terms of latency, when we are saying it's latency converting from 100 millisecond or could be multiple milliseconds to few milliseconds or microseconds or nanoseconds. So the edge is something that comes into picture when we are talking about, during the processing time, right? The data that is coming from your edge devices Or for example, I can take, let's say in 5G, right? We have our, your radio units, your users, radio units, and CUDU. Before this, we were having the baseband units, right? And we were having just the core, which is there on the cloud. Now we are talking about moving everything on the edge. For example, whether it is centralized unit, distributed unit, now RIC as well, right? Basically to optimize the RAN network. Now, why all these changes are happening? We want to reduce the latency, meaning converting the data transfer from, or the response time from few hundred millisecond to microsecond or nanosecond, right? So as I was talking about CUDU and RIC coming close to the edge, that is one use case, right? And why we want to do that, right? Now let's think about a situation if we do not go for edge, we have a cloud, centralized cloud. Now you imagine your large packet data, right? Whether these are IoT sensors or any other device, they're sending large amount of data, right, to the cloud server, and cloud has to do the data processing, and the decision making has to be done on the cloud. Instead, if we move everything, all of this processing and decision making to the edge, which is close to my end user, right, we would be reducing the time like anything, right? Whether it is micro nano, it's based on the applications that we will have. Right. Another benefit that we see is the bandwidth usage. So if my packet size is pretty huge, right? If instead moving this data from, from my edge users to the cloud, instead I will process everything on the edge, right? The bandwidth utilization is pretty high here, right? In case of cloud. With edge being coming into the picture, we are saying the RxTx would be reduced heavily because everything is processed internally within on the edge side, right? There are multiple use cases and applications for it. For example, autonomous vehicle is another. We want everything. So in autonomous vehicle, what happens is we call it as a AI box or a, any edge box which is there on the vehicle itself, which has to take the decision based on the obstacle coming in the front or anything, any motion detection. So it has to take a decision, or maybe based on, let's say there is a driver solution that we built, right, for end customers. For example, you might be knowing the Amazon trucks are there, and they are having the video cameras on these trucks. So the driver drowsiness and all of the other behaviors have to be detected on the edge. Now imagine if this being happening on the cloud, there would be huge latency. So yeah, this is where the edge computing comes into the picture. There are multiple other benefits we can talk about. For example, the cost efficiency, and another important point I would talk about is the reliability. See, having everything on the edge, we are saying things would not be transferred to the cloud, or I would say just the metadata, the important data which is there required for the decision making is there on the edge. Just the metadata goes to the cloud. Right, so all of these benefits of the edge computing comes into the picture and brings the latency benefits as well. Thank you.
Thank you, Sumit. The fusion of cloud and edge computing is also creating almost a tech revolution, especially with 5G, 6G, AI, ML, etc. I wanted to turn to Rohit for this and probably come to others. Um, how does the convergence of cloud and also the edge computing impact the development of emerging technologies like AI, ML, and 5G, 6G, etc.? And Girish, feel free to chime in.
Yeah, so I'm from HP and
Closer.
yeah, so we largely focused on infrastructure technology, and from last, I would say about a decade, we were focusing more on the hybrid cloud side, right? So people running their application on cloud, and then they started coming back onto the data centers. So the whole thing became very complex for most of our customers. So that's where we were largely focused on hybrid cloud. Now, from last few years, what we see as all our co-panelists talked about edge use cases and various edge applications, especially of the emergence of 5G, right? So now data is really getting generated. Most of the data is really getting generated at the edge, and extend also at the edge for the low latency and the real-time kind of use cases, right? So that's where we started creating a platform which can cover cloud to core to edge, right? So we talked about the use cases, we talked about the various application and connectivity, but how do I manage? I was able to manage my cloud platform or on-prem platform in a hybrid way. My developer was able to spin up the application. They were able to use the DevOps process to run their applications. I had the complete visibility of my the infrastructure application running on cloud, on-prem very clearly. Now, how do I span same thing at the edge as well? So that's where the platform which we created, which covers cloud to core to edge. So now from a single platform, what I'm able to do, not only I'm able to give the visibility of all my infrastructure and application which is running, also I'm able to provide the same experience which my developer or the users had in cloud or hybrid cloud world, which is a self-service way, pay-per-use, API-driven, DevOps way of deploying my applications, right? So that's where we see the convergence of, the edge and cloud really happening, and a platform which can give them the same or similar kind of experience which they used to get about 5 years back in their cloud is what something we feel is necessary today, and that's where the whole convergence is really happening. Second thing, when you have this data created at the edge, so cloud is just not about self-service and looking at your the infrastructure at one place. It's also about looking at your data, right? So now with the edge, you are actually creating a silos of data. So how do I consolidate my data, have a same level of security spanning across my cloud to core to edge? So that's another area which we are kind of trying to work with from our edge to cloud platform.
Yeah, thank you, Rohit. Girish, anything you wanted to add?
I would like to definitely add here, coming from Geo, so where we have been like a torchbearer of creating a world's largest, 5G data network. So just a small question: that how many of you have watched IPL on Geo Cinema? I mean, most of you. I mean, I was very much expecting this. Now I'll give you a very nice, use case around this. But before that, I would like to just draw one line here: is that there is an enormous, or I'll say a very powerful synergy among five technology today. One is the cloud, edge, 5G, AI, and the automation. So these are the five things are like going hand in hand. I'll give you a live example of this IPL use case, that how we have amalgamated all these five technology for all the fathomable reasons for you to further extrapolate, and the opportunities are limitless, boundless. In this IPL match, interestingly, if you all give some focus on it, we have totally leveraged our 5G infrastructure at the first place, and we have created a large amount of the edge network, which was basically the backbone for streaming this adaptive rate geo cinema content. And most of you were viewing this in a very seamless manner if you were using the geo true 5G network. The technology behind was that essentially consisting of these five elements. We created 400 edge centers all across the India. These edge centers were catering to the user plane function, which was again coming from the 5G service-based architecture. Again, I am saying that since it is a true 5G based on the 5G standalone architecture and not a recycled 4G as we see in the other cases. So with the help of the 5G standalone architecture, we could create a distributed architecture, harbor the power of the cloud and the edge architecture, bring this power of the two architecture together, and stream this IPL match with a zero, almost a very negligible latency. And you would be surprised that the Geo Cinema witnessed highest, 68, 63 crores of the viewership, which is like a 630 million views, which is the highest in the world. And that's what has made us the largest data network operator in the world. That is one thing. Another thing is that within this cloud edge infrastructure, we created, as my colleague said, the three layers: edge, core, super core. The core was another, a kind of a standby Mac, the edge location where we deployed our CDNs, our GeoCinema application, which was also on standby on the Mac application as well. And then we have a super core or a super cloud location where we were managing entire show from there from the network management perspective. So with this amalgamation of all these five technology, you can see that we could stream this. And this was for the first time that such a large event was streamed on your mobile phone, smartphones. The number of viewers on the smartphones was far more higher than the television, the linear TV channels. So this was one for the first time, kind of thing has been successfully, ran in the country. And thanks to this 5 technology, and last but not least was the AI and the automation, with the help of which, when you have the distributed infrastructure, you need a very strong automation in place, so that you can create the infrastructure in no time by not relying on too much of mobilization of the human resources traveling from pillar to post. And when you talk about the edge, basically you need to be very agile. When we were creating these edge locations, many of the edge locations we were doing it on the fly, and this number is still going on. And who has helped us, realize this vision was the automation story. And then came the AI, with the help of which we could take the preemptive measures. We could, take a closed loop automated feedback mechanisms, correct the problems before they occur. We could, predict the network anomalies, and that's how this whole, stories, all these dots, when you join together, it gives you a very beautiful story about how you can harness this technology for realizing this kind of, the use cases at scale, especially in the context of the India, where we have a very large set of population.
Thank you. Thank you, Girish. Sumit, coming to you, I'm as curious as others about some of the innovative applications of cloud and edge, especially in industries like financial services, transportation, finance, etc. Anything you wanted to share?
Yeah, sure. So there are multiple applications actually which I would say have already been applied in this real world, or which can be built. So I'll give examples of both. So I'll start with, for example, just like you said, healthcare, right? So the one of the major application that I can see is there today and can be improvised as well in the future, the AI assisted diagnostic. So for example, today when we go for any diagnostic, right? For example, whether it is a X-ray or any MRI or anything like that, right? We get the reports done from these diagnostic system. Then we go to the doctor and we show the reports to them, right? So there's a delay for sure, getting the reports from the diagnostic systems and going to the doctor, and there would be some delay. So what if we would have AI-assisted, diagnostic systems? So what would happen is these machines, whether it is an X-ray machine or an MRI, would do some initial analytics in itself, right? So that is happening on the edge, so that the person or the patient would get some initial analysis about his or her health, right? So these machines, I would say, would have the AI analytics built in, happening on the edge. Patient would get the analytics done at the same time, and the precautions or anything that has to be done, right, for prescription has to be taken from the doctor, can be done right on the second phase itself. So that is one application I can see in the healthcare. Right, and the second one is we all know about this wearable monitoring system, right? So think of, you have a blood sugar monitoring or glucose monitoring. These all devices are these are the devices which you set up, and these can be used, I would say, in hospitals as well as at home as well, right? So what will happen is, consider these devices as the edge itself, the analytics happening in the edge itself. The benefit is the BP or sugar or any other important vitals that we want to know from the patient perspective, that machine can take the decision and alert your medical staff or the doctor, right? So that any specific prescription can be started real time, or with huge delays, right? So now switching to let's say finance, right? We all do the stock market, and we all do this high frequency trading system, right? So what happens is this is already there. These applications are already there on the edge. So the edge servers are actually deployed very close, or I would say co-located to these exchanges, so that whether you want to purchase or you want to sell any trade, the buying or selling of a trade can happen almost at the same time. We want here millisecond or microsecond of a delay, because we want the buying and trade has to happen almost at the real time, right? So that is in the finance domain. There are multiple other examples. Now, talking about the transportation, right? So one real use case I would like to see maybe in near future right? I'm not sure if it is already there. The smart traffic management. So these days, when we are on the road, we know the traffic lights are having some static time. The defined timings are there, right? What if we apply AI into it, meaning happening on the edge? We will have the edge servers, and based on the congestion on the road, the decision can be taken whether the traffic light timing, it should be 60 second, 30 second, 120 second. Basically, I'm talking about the dynamic traffic light timings, which can be implemented as an application for edge computing, right? So smart traffic management is another application. Another application is in transportation is connected vehicles. I believe we have been talking about this connected vehicle, and I believe this application is being deployed at some part of the world as well, right? What happens is all the vehicles which are on the road, they are connected to each other. So if they're connected to each other, meaning all the vehicles are having the edge devices itself, and these all edge devices talk to each other. Benefit is, again, we'll get to know about the real time traffic situation or the infrastructure, the road infrastructure. All of these things can be determined almost at the real time, right, in the transportation system. So these all applications I can see as a important and the high value advantage for edge computing. Thank you.
Thank you, Sumit. Talking of traffic, already it's in motion. In Bangalore, for example, variable time traffic lights, technology commercialized by CDAC. And there is also other side. For example, if you go from Bangalore to Mysore, again, AI-powered systems, not only detecting whether you are speeding, but also it measures, how much time you are taking between one camera and another camera also, right?
Yeah.
So very interesting use cases already in action in India. Ankur, coming to you on, I just also wanted to kind of understand perspective about the role of networks when it comes to this convergence between cloud and edge. You want to keep it quick because I'm not too sure whether the word has gone out about how interesting this session is so that suddenly the room is full, or they are there for the next session. Okay.
No, I'll be quick. So when we're talking edge, we're talking about, again, taking applications, processes, storage as close to the customer as possible. So, these customers, as I said, or these could be devices, IoTs, robots. Now, when we talk about networks, I look at it as two steps. One is the devices, the robots, the IoT sensors connecting to the edge node, and then the edge node connecting to the data center, which is the larger cloud. Look at edge as like a distributed cloud. So on the first part, which is more access, you have technologies like 5G, FWA, private 5G coming in, and those technologies on networks needed to support huge amount of devices and of course low latency. The other piece is really connecting the edge nodes back to the data center. And that is where, we have to be very careful as to what network technologies can be deployed. These technologies have to be, one, highly resilient, highly scalable, low latency, and fiber then becomes the obvious choice for this connectivity. So I think there is a need for some newer, custom-built, purpose-built fiber networks, which could be kind of express layer built between these edge nodes to the data centers. And also offering I think this is all a puzzle of larger part of the larger puzzle of digital infrastructure as a service, and to be able to then offer these fiber-based services to edge users on self-service models. Could be bandwidth on demand, could be selecting routes that you prefer to use. So kind of make them more software defined, if you may. I think that's the role the network would play.
Thank you, Ankur. Jayant, I know you are part of some of the standards bodies as well. Think of it like a rapid fire question. So what role do interoperability and standardization play in ensuring kind of seamless integration across different platforms and devices?
Look, I think it's an important one. One way to think about it is we're all sitting here in Delhi. We heard the Prime Minister say that there's more than 3,000 delegates here for a standardization event from 190 countries. I think that says a lot about the importance of standardization, right? The ITU has been doing a phenomenal job. The ISO, the IEC, many others, some that I have the privilege to be a part of. I think standardization is certainly important. I mean, we've all benefited from technologies that, like HTTP, for example, right? That underpins pretty much everything that we do, including most of the APIs. So I don't think standardization is something that needs to be sold to anybody, because I think we've seen the benefits of it over the last decades, especially with the way computing technologies really benefited from it. Interoperability is interesting. Given that we're talking about edge devices, a lot of IoT, hands up for anybody who has struggled to integrate a new device into their smart home, right? I'm sure half the hands will go up here. The reality is interoperability is challenging very often. So standardization does have a role to play. Having a common set of principles that don't exclude a set of vendors, but at the same time maximize the diversity of devices as well as technologies that you can incorporate for use cases, I think is a common good. So I'll keep it short and I'll keep it to that. Happy to go into further detail if anybody needs to.
Thank you, Jayant. John, anything you wanted to add on standardization and interoperability?
No, I think as we're combining the edge and the cloud, these new services that pop up there's going to be a temptation to really make them very vertically integrated. And I think that will be the first step, but I think ultimately that will limit the connectivity and the kind of services that we can offer to our customers. So, a second.
With that, I wanted to thank all the panelists for sharing different perspectives, whether it was use cases or infrastructure or standardization. And in case you came a bit late, there is a part B of this session with a different set of panelists in the same room. So I'm sure that will be as exciting as this one. Thank you, everyone, for sharing your thoughts, and thanks, everyone, for listening in. Unfortunately, we don't have time to take questions. Okay.